Hello, friends. Grab your coffee, grab your cookie, and please do not create any sparks while we talk about today's topic. Because today we are dealing with something much more serious than regular dry dust. We are talking about aluminum dust, one of the most explosive and unpredictable industrial dusts you can ever meet. My name is Michael Klepik, and for 15 years I have been working with systems that keep dust where it belongs, inside the filter, not in your lungs, and definitely not in a fireball. So let me break this down in simple, clear language. What aluminum dust really is. Aluminum dust is extremely fine metal powder produced during grinding, polishing, sanding, cutting, and finishing of aluminum parts. Typical particle size ranges from 1 micron to around 60 microns, with a very large fraction smaller than 10 microns. Here is what makes aluminum dust so dangerous. First, it is a combustible metal dust. Second, it forms explosive dust clouds even at low concentrations. Third, it ignites easily when exposed to friction, sparks, or static electricity. Fourth, it burns at extremely high temperatures once the reaction begins. Aluminum dust has what we call a very low minimum ignition energy. This means even a small static spark or overheated bearing can be enough to start an explosion. So yes, aluminum dust is not just a nuisance. It is a real hazard that requires a completely different approach compared to cement dust or wood dust. Where aluminum dust appears in industry. In most metal working facilities, aluminum dust is produced in several main operations. First, grinding and sanding aluminum surfaces. Second, polishing and buffing stations. Third, CNC machining and high-speed milling. Fourth, cutting, trimming, and deburring operations. Fifth, powder handling, mixing, and recycling of aluminum fines. The dangerous part is this: aluminum dust does not need high concentration to become explosive. Even thin layers of settled dust can ignite if disturbed and resuspended in the air. Why aluminum dust explodes? Let me explain the physics in a simple way. Aluminum is a reactive metal. When it exists as a bulk solid like a sheet or block, it is safe. But when turned into fine dust, first, the surface area becomes extremely large. Second, the particles oxidize rapidly when exposed to air. Third, each small particle becomes fuel, and oxygen becomes the oxidizer. Once a dust cloud forms, all it needs is an ignition source. The result is a flash fire or a dust explosion. That is why NFPA standards classify aluminum dust as a hazardous combustible metal dust. How I design a safe filtration system for aluminum dust. For aluminum dust, safety comes before everything else. I never design these systems the same way as I do for cement or wood. Here are the key principles I always follow. First, the entire dust collector must be fully grounded and bonded to prevent static buildup. Second, the dust collector must be designed for explosive atmospheres, including proper explosion venting. Third, sparks, friction, and heat sources must be eliminated from the air path. Fourth, the airflow velocity must be high enough to transport aluminum dust without settling, but not too high to create dangerous friction. Most aluminum dust systems require air velocities from 4,000 to 5,000 feet per minute in ducts to prevent accumulation. What filtration equipment works best for aluminum dust? I recommend two main options depending on the type of process. First option, a wet dust collector. Wet collection is one of the safest methods for aluminum dust because water neutralizes the combustion reaction. At Torch Air, we use wet scrubbers specifically built for metal dust, where dust is immediately submerged into water. This prevents ignition, reduces oxidation, and keeps the system cool. Second option, a cartridge or bag collector with explosion protection. If the process requires dry collection, the system must include, first, explosion vent panels designed for combustible metal dust. Second, a safe discharge route away from people and equipment. Third, a rotary airlock designed for hazardous dust. Fourth, anti-static filter media. Fifth, a fan that is non-sparking by design. For fine aluminum dust, a FOE-HN cartridge system can be used, but only with proper explosion venting and grounding. For heavy loading, a reinforced baghouse such as the Blizzard model can be applied, again with full explosion protection. The most common mistakes I see. Let me list the mistakes I encounter most often in aluminum operations. First, using a standard dry dust collector without explosion vents. Second, installing non-grounded ductwork which allows static to build up. Third, running transport velocity too low, which causes dust to settle and create a fuel layer. Fourth, connecting aluminum dust to the same system as other materials. This is extremely dangerous. Fifth, attempting to collect aluminum dust with a vacuum cleaner not rated for combustible dust. Any of these mistakes can lead to a fire or an explosion. What I always do on aluminum projects here is my standard checklist. First, I verify that all ducting, collector parts, and equipment are fully grounded. Second, I check that explosion vents are correctly sized for the collector volume. Third, I ensure the system has no internal ignition sources. Fourth, I calculate duct velocity specifically for aluminum dust. Fifth, I choose filter media that prevents static buildup. Sixth, I make sure aluminum dust is collected separately from any other dust type. These steps are non-negotiable. Aluminum dust is not something to underestimate. It is reactive, explosive, and extremely dangerous when handled incorrectly. But with the right equipment, proper airflow control, and explosion protection, aluminum dust can be managed safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and most importantly, protect your facility from sparks. In the world of aluminum dust, safety is more than a rule. It is survival. See you in the next video.